All right, basic probability. So the probability you look amazing today, 100%, also 100%, but in yellow to make time right. Okay, so flipping coins. If you flip a coin 10 times, how many times would you expect it to come up heads? Well, we have a 50-50 chance, so you would expect it to come up heads 5 times, right? This is called the expected probability. Or no. That is the expected probability, which is also called the theoretical probability. Okay, that's what we're expecting to get when we do this. Now, if we actually do this, so I did this, and I did heads, I flipped it, and I got heads, tails, tails, heads, heads, tails, heads, tails, heads, heads. So I got heads 6 times, which means my probability, my actual probability was 6 out of 10, which was 60%. Okay, this is called the experimental probability because this is the probability we got when we did an experiment. Cool? Now, rolling dice. So when you roll dice, there's 6 sides on the dice, right? So we want to know what the theoretical probability of rolling a 6 on a dice is. Well, there's only one side with a 6. So it's going to be 1 out of 6, which is 0.167, which is 16.7%. Okay. So if we roll a dice 24 times, we want to know how many times we get a 6. So I rolled a dice 24 times, and this is the numbers I got. So I got 6, 1, 2, 3, 4, 5 times. So that's 5 out of 24, which is 2.8%, or 0.208, well, sorry, which is 20.8%. So my experimental probability was 20.8%. Okay. Now this one, so we have dependent and we have independent events. This one that we're going to do right now is an independent event. So if we roll a die and flip a coin at the same time, this table over here gives us our possible outcomes. So like this right here is saying we rolled a 1 on the die and we got heads. This would be we rolled a 2 on the die and got heads. This would be we rolled a 5 on the die and we got tails. Okay. So we want to know how many possible outcomes there are. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 possible outcomes. We can just count them. Okay, so you could get a head and a 1, or head 2, head 3, head 4, head 5, head 6. Or you could get tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. So there are 12 possible outcomes. We want to know the theoretical probability of rolling a 3 and flipping a head at the same time. Well, the probability of rolling a 3 would be 1/6. And the probability of flipping heads would be 1/2. And when you have more than one event, you multiply the probabilities together to get the total probability. So we're going to do 1/6 times 1/2, which is 1/12, which is approximately 0.083, so that's going to be 8.3%. We have an 8.3% of rolling a 3 and flipping heads. Okay? What is the probability of getting a number less than 5 on the die and the coin landing tails up? So less than 5, that would be 1, 2, 3, or 4, because 5 is not included in there. So that would be 4 out of 6, which is 2/3. Landing tails up, well, we still just have a 1/2 chance of that. So then we do 2/3 times 1/2, which is 1/3, which is 0.333. So we have a 33.3% chance of doing that. Okay? And these are called independent events because what I roll on the dice is not going to affect what I'm flipping on the coin. Okay? Because the outcome of one does not affect the outcome of the other. Now let's do this one. Suppose that 10 names are in a box for a drawing to win a prize. There are 6 boys' names and 4 girls' names. And we want to know the probability of drawing a boy's name and then drawing a girl's name. So first we want to know what is the probability of drawing a boy's name. Well, it would be 6 out of 10. which is 3/5, which is 0.6. So that'd be 60%. So once the boy's name is drawn, how many names are left? Well, there'd be 9 names left because we started with 10, we drew 1, we're left with 9. How many of these are girls? Well, we still have all 4 girls' names in there. We haven't pulled one yet. So what's the probability of drawing a girl's name on the second draw? Well, it'd be 4 out of 9, 0.44, so it'd be 44.4%. So what is the probability of drawing a boy's name and then a girl's name? Well, we could just multiply those two together. So we do 3/5 times 4/9, which is 12 out of 45, which is about 2.67. So there's a 26.7 chance that we'll draw a boy's name and then we'll draw a girl's name. Okay. So these are dependent events because the probability of drawing a girl's name after a boy names depends on that first event. Okay, this is an example of a dependent event because it changes the probability for the next event. And that's it. Bye.